Okay, we're 23 hours in, guys. Like this is like I got my virtual background where the marathon is nearly finished. Trust me, that's the last I'll do of that background. Let's get rid of that. But if you're joining the call late or you've been on, like Rick has been through the whole session, we have nothing but admiration for any amount of participation you've had on this call because it's been a fantastic event and hopefully you've got as much value out of it as I have and everyone else on the call has. Let's share my screen and get into it. Hopefully you can all see that. And the reason I put that up there is people of my generation, you may be familiar with the old show called 24, where we sort of always had the countdown at the start of the session. And then we had the following takes place between. So, excuse me, we're up to the last hour. Hopefully we can stick through it. Oh, my throat. Oh. Excuse me. Okay, my name's Connor McDonald. I come from Perth. And for those that don't know where Perth is, it's on this side of Australia. And it's funny how only 2 months ago, this was the slide that was gaining the attention. I would put this slide up and talk about bushfires in Australia. And it's funny how the world changes so rapidly to items that are far more significant and far more global in nature. And the only reason I wanted to put the standard COVID slide up is just to reinforce that, you know, as part of this fantastic event, the objective here is to stay safe because, you know, it doesn't really matter if you have a community program if you don't actually have community to actually take part in it. So even though we're stuck working from home and soon hopefully we'll be back working in our offices or wherever, make sure we stay safe, make sure we stay healthy. That's the most important thing. Okay. What are we going to talk about? This is how you get in touch with me. There's my blog, my Twitter, my YouTube account. In terms of this last session, I will stress I'll take all the questions offline after the session and I'll do a blog post answering any questions you have. And in that way, we'll have time for Martin and Joel to officially wrap up the session. So I'll probably go to about the 50-minute mark and then I'll take your questions offline. I hope that's okay with you. But obviously, if you have other questions after the session, reach out to me via my blog, via Twitter, or check out my YouTube channel. Just to add to the concept here, if you're liking this virtual concept, sometimes it's not ideal, we'd rather be face-to-face, but if you are, don't forget that as well as Apex having their office hours, the entire Oracle database organization runs office hours as well. You could almost think of us as pioneers because in the last 2 years, we've run over 300 virtual events as part of the office hours program. Some in Apex, some in database, in memory, optimizer, clusterware, you name it, machine learning. We actually have about 2 to 3 of these every single week. So there's over 300 already recorded out on YouTube, and obviously there'll be more to come. So SQL, it seems an interesting one because this is fundamentally an Apex event, so why talk about SQL? And the big question is why? Why do we want to talk about SQL? Because SQL, it's an interesting one because after all, it's old. SQL is very old indeed. In fact, if you go back to Microsoft version 1, Windows version 1, SQL predates that. SQL came out before Windows environments even existed. I have a couple of reasons why I like to talk about SQL at anything which involves application development, including Apex. First of all is this term, NoSQL. What a terrible term that was. And the reason I stress this is I have no issues with the technology, the NoSQL technology as an architecture, but really they should have called it non-relational. It's got nothing to do with the SQL language. And in particular, even the inventors of most of these NoSQL technologies, the Googles, the Facebooks of the world, are all realizing that SQL as an interface on top of data is pretty much the de facto language. All these technologies now are looking at having a SQL interface on top of it. The second reason I want to talk about SQL is when it comes to Apex in particular, Apex lives and dies on the quality of SQL that you can write. And it's funny how Apex is almost a trip back into where I started in programming, which was your application spoke directly to the database, which I think is a fantastic thing. You get fantastic features available to you, you get fantastic scalability, but you are also, as a developer, very, very responsible for the speed and scalability of the applications you write because you are almost at one with the database. It's funny how in these modern development environments, It's interesting how like the database is sort of surrounded by many, many, many layers. And it's almost a benefit for developers in those systems, because if you have a problem in the database, it doesn't matter. You can blame it on any tool, the Memcache layer, the Kubernetes layer, the Docker layer, the virtual layer, etc. You have that luxury of being able to blame it on a million components. And of course, if you're using something like microservices, the joy there is, as a developer, if you have problems, it doesn't matter if they're a SQL problem. You'll never know. You'll never be able to diagnose it. But for us, Apex, being so close to the database, lets us get incredible benefits, but also ties us into the quality of our SQL. Now, a key point in this session is not about being a smartass. It's not about trying to show you realms of incredibly complicated SQL and going, oh, look how smart we can be, for no real value. Because the reality is you can do anything in SQL. SQL is Turing complete. So anything that you could express as an algorithm, you could actually solve with a single SQL statement. That doesn't mean we should. Let me give you an example of what we're not going to talk about today. Here's the first page of an SQL. Here's the second page of an SQL. I didn't write it. It's written by a friend in the Netherlands called Anton, a very smart guy. What does it do? Well, if you can pass in some sort of representation of a Sudoku board, it will actually go ahead and solve it for you. Now, that seems insane, but there's the solution. Now, you might be thinking, well, you've just glossed up a bit of PowerPoint here to actually make me believe that could solve Sudoku. But I want to be a man of my word. Let's have a look at it in action. Hopefully that font is large enough. There's my Sudoku board coming in as a varchar2 string. I've just put some nice little columns and dots in there for missing 9, so it looks like a Sudoku board. There's the first page of the SQL. There's the second page of the SQL. We give it a run, and there's the solution. It solves Sudoku with a SQL statement. Now, you might be thinking, I just sort of, a bit of smoke and mirrors here. Let's take out the terminating condition you can actually watch this in action. And Zoom will struggle to paint that, but you can see it brute forces the 81 digits required for Sudoku. And at the end, I just do a bit of formatting to make it look a bit nice. But as you can see, you can actually do anything with SQL. Now, let's face it, the percentage of us as developers who need to solve Sudoku as part of our job, I would imagine is very, very low. Whereas the percentage of us that need to get real stuff done is obviously very high. That's why we're on the call. So this session is about real stuff, not trickery with things like Sudoku and the like. So we're just going to charge away and get as many done as we can in the 50 minutes we have, and then we'll call it quits. So a bit of controversy to start with. If you want to be a successful SQL coder, you need to be friends with your DBA. Now that's a tough one because there's often a chasm between the DBAs, the administrators, and the developers in an application. And sometimes it's just a logical division, but sometimes it's physical. Sometimes you're in a different office, a different building, a different state, a different continent sometimes. So that chasm is often all too real. And sometimes it's a cultural one as well. You ask often a developer what they think about the DBA, and they say, oh, that's that old guy, and he's got strange taste in footwear and strange taste in drinks. And, we try to steer clear of him. He's always grumpy. And you go ask the DBAs, what do you think about the developers? They go, oh, that's those Red Bull drinking, Justin Bieber loving, don't know how to wear their jeans properly group over there. There's often friction between DBAs and developers. But that DBA relationship is super important. And let me prove to you that with a real example. So I'm going to create a table called My Transactions 1. It's going to simulate some customer transactions. You can see it's got a customer ID, a transaction ID, and it starts off as empty, and we're going to insert 200,000 random rows. I've got a table there called tab 200K. It's just got some random data, but I'm also using DBMS random to ensure I've got random information in there. I've got 200,000 rows in there. Let's do a sample query, a typical application query. A customer logs on, in this case, it's customer 160, and they want to see all their transactions. The key line in this output is the line that says consistent gets. Let me highlight that. 529 it costs. That's the amount of IO workload to do to run this query. That's slightly inflated because the first time we run a query, you have to work out how to run it. So once we got that information, the second time it's a bit better, it's 378. But now that that query is locked into the library cache, that's repeatable. It's consistent. 378, 378. I'm hitting return here in case the Zoom isn't refreshing. It's always 378. That's what it costs to get customer 160's transactions. Let's create my transactions 2. Exactly the same column structure, customers, transactions, etc. It starts off also as empty. I'm going to copy my transactions 1 into my transactions 2, so they have exactly the same data. Let me validate that. They both have 200,000 rows in them. I can do a minus query, which says, show me everything from transactions 1 that's not in transactions 2, and vice versa. No differences. They are identical. They have the same index structure, a single primary key on customer ID and transaction ID. Let's refresh our memory. My transactions 1 for customer 160 is still 378 consistent gets. It's unchanged. Let's now run that same query, same customer, same data for my transactions 2. It's 103 consistent gets. It's 4 times faster. And don't forget, this is the first time I ran that query. This is the expensive version of that query. Now that I know what my transactions 2 queries are framed like, now it's 22. It's 20 times faster to query my transactions 2 with the same column, same data, same indexing structure. That's the importance of knowing how to have a relationship with your DBA. The DBA, if you can go to them as a developer and say, these are the things that are critical to me. These are the operations that are most important to me in my Apex application. As DBAs, they can frame the database structures and come up with the appropriate designs to make sure your application will scale. Don't get me wrong, Quick SQL is a fantastic tool and I encourage its use. It's a great way of what I say, getting your application to run. And once your application is running, to really make it sing, that's when you get your DBA and your data modeling involved. So I view it as a 2-step process. Quick SQL gets you prototyping, gets you even into production with an application that will run. When that application is ready to go really prime time, it's going to have to meet its scalability requirements, its performance requirements, etc. That's when your DBA and data modeling can really help lift it to the next level. Number 2, query block naming. I need to paint this feature with a little bit of a backstory here. I worked with a customer some years back and they'd written an application in a mixture of technologies. They had Unix part components and Windows parts, so it was C#, C++. They were using a service bus, all talking through Oracle Tuxedo via WebLogic to the database. Beautiful code. When we looked at all the SQL, that SQL looked fine, but then application ran terribly. And when we did some examination, what was happening was it was extremely chatty. Thousands and thousands of very simple, small SQLs coming across the wire to actually satisfy a single application function. That's why they called me and they said, the database is slow. And when we looked, it wasn't the database, it was just that back and forth chattiness. So my job was to simply take a lot of that code, refactor it into stored procedures, not change the SQL, not rewrite the application, just take 10,000 SQL statements out in C# land, put them into 10,000 SQL statements in a Peel SQL procedure, run them all as single blocks in the database. It's not perfect, but it's better than across the network, and then send the results back, just to reduce the latency. So the challenge there for me was actually refactoring C# code into Peel SQL. And at that stage, I didn't know any C#. And when I looked at the C# code, it was a bit hard to get my head around it because there were no comments. In fact, I was so sure that I was missing something that I actually Googled for the C# comment sign, but no, I was correct. There was actually no comments in there. And when I went to the developers, I said, there's no comments in the code. They said, that's okay. C# is self-documenting. And of course I went, oh yeah, thanks a lot. So that was a bit of an ordeal for me, but I realized I was being perhaps a bit of a hypocrite because the C# was complex, but SQL can be complex as well. In the absence of comments, and often we don't put a lot of commentary in our SQL statements, maybe SQL should self-document as well. Now, part of that is good table names, good column names, etc. But also, what about the structure of the SQL itself? Can I make that self-documenting? And that's where query blocks can help you with self-documenting SQL. Let's look at a complicated SQL. And I call this one complex because the employee table is referenced 3 times. When I look at the execution plan, I can see the employee table also appears 3 times in the plan. But how do I map the employee table in the query to the employee table in the plan? What's the deal here? Like, is it just top to bottom? How do we work it out? And so query blocks are a specialized comment or a specialized hint that can assist here. So I've inserted a couple of query block name hints here. I get 24 characters to put in those brackets. The first one I've called the year someone was hired, because that subquery represents the latest year someone was hired from the employee table. The one in green, I've said it's AV sal. It's the average salary per department. The outermost query I didn't give a name to. Let's now look at the execution plan again. One of the columns that you get inside the plan table is the query block name. And once you have that, you can annotate your plan, for example, as you can see on screen there. Now I can actually sort of drill into the plan. I can see that the middle section was about the average salary, even though it was the last query in my original SQL. The average salary, the year of hire was the bottom part. So it's a great way of digging into a complicated plan. That's better than standard commentary you put in your SQL code, because that only appears in your source code. In this case, with the QB name hint, it's being captured in the plan, it's being captured in your 10053 trace, etc. It's a specialized comment that's known to Oracle. Number 3, a partitioned outer join. Let me set the stage with a bit of some sample data here. Let's say I'm building an application where you can book rooms for a meeting. So these are the available time slots you're allowed to book a meeting for, somewhere between 8 a.m. and 4 p.m. And I'd love to work in that workplace. And here are some of the existing bookings. I've got Pete has booked room 2 at 8 a.m., John has booked room 1 at 9 a.m., etc., etc. If I want to see the bookings for each hour, that's just a conventional outer join. Most of us will be familiar with that. We simply join the time slots with a left join because we want to fill in the blanks of all the potential hours, and we simply assign rows from the booking tables into our result. So I'd say everyone's familiar with a conventional outer join, whether you're using ANSI standard SQL like this or the Oracle SQL. What if I want the bookings by hour for each room that bookings exist for? That's a bit more complicated now, because now I want a row like that, or a set of rows like that for room 1. I want a set of rows like that for room 2. And of course, the number of repetitions of rows I want is actually dependent on the distinct number of rooms in my bookings table. The moment someone books room 3, I need 3 sets of rows. Room 4, 4 sets of rows. Normally, we have to solve this with self-joins and select distincts, etc. But the partitioned outer join solves this for you with literally a trivial addition to the existing SQL. I simply take my SQL and do partition by. And that's enough for the database to know that what you want is a complete set of outer joins for each distinct value of the rooms in the bookings table. So I get a set of rows for room 1, a set of rows for room 2. If someone creates a booking for room 3, I'll get another set of rows as well. That's pretty cool. If you think this is some brand new feature that you'll have to wait for 20C to get to, this came out in Oracle 9. One of the nice things is that lends itself really nicely to multiplying row sets for Apex reports, because one of the nice things in Apex is, of course, you can do control breaks for changing of room values. So once you have your partitioned outer join, trivial to mold that into then a control break Apex report. Number 4, subquery factoring, also known as common table expressions, also known as the with clause. You can take any query in the Oracle database, wrap it with a with clause, and give it some nice name. So in this case, I've got last hire being effectively a synonym for a table, which that table being select department name, max hire date, etc. At which point you're going, wow, you took 3 lines of code, you made it 6 lines of code for the exact same result. Where's the benefit, besides unless you're getting paid by the line of code? Why is it cool? Well, it's a great what I call solution metaphor. And to help explain what I mean by that is, most of us are dealing with relational databases, and relational is a rigorous model. It's based in mathematics and algebra. And as we know, it's generally the dominant model for databases out there today. Independent of the vendor, relational generally is the dominant model. But also relational, it can sort of suck. And don't get me wrong, it's not our fault. We're developers. It's never our fault. I blame these guys. These are the guys that invented the thing. And when you go look at the relational theory papers, you get stuff like this. Data is represented as a mathematical n-area relations, and area relation being a subset of the Cartesian product of n domains. I don't know about you, but when I see that, I think, I have no idea what that means. For me, relational databases always were Excel, but bigger. That's pretty much how I got into working with databases. The problem is humans don't think relationally. We don't think in terms of set algebra and mathematical models. We think procedurally. Procedurally being do step 1, do step 2, do step 3. Someone tells me to go to the shop. I don't think about set theory. I think about jumping in the car, driving, getting some stuff, coming home, having a beer. Step by step is not the relational pattern though. So you can think of developers as being a black box that turn procedure into relational. And this is what we have to do as developers. Someone gives you a procedural specification. First, get the total salary paid by each department, then get the average of those totals, then list the departments above that average. That's a set of steps to do. And then we say, turn that into a SQL statement. That's your job. Often we see that and we say, oh, I'll do it in PL SQL because it has to be done step by step, but it's not. Here's where the with statement is great. I can tackle a problem step by step. First, get the total salary by department. I'll just focus on that. Here's my query, department salaries. I'll write a query to satisfy that requirement. Department name, sum, salary, etc. Then get the average of those totals. Cool, I've got this thing called department salaries now. I can use that for my next part of the with clause. I'm going to create a table, inverted commas, called average sal. And that's going to be select average sal from department salaries. Then list those departments above the average. I can focus just on that requirement now. It's a simple join between the two things I've just created. Department salaries and average salary. Join them to see where one's bigger than the other. And I'm done. The cool thing there is I've got a single SQL there that satisfies the requirement of a step-by-step procedural specification. I took a programming approach. I broke a problem down into smaller components, but I still came up with a nice single SQL relational solution. That's why I love the with clause. It lets you think like you would like to think as a programmer and still come up with beautiful SQL at the end. The other great thing with the with statement is it sort of embodies the concept of what we often used to call code reuse in the programming paradigm. Let me give you an example of what I call the finishing touches. Nowadays, everyone loves JSON. Everyone's invested in JSON. It's the thing to, if you want to be one of the cool kids, you've got to know how to use JSON. Let's go back to our partitioned outer join example. Here is the final SQL statement we came up with, which obviously returns us rows and columns. Perfect for Apex. Then someone says, oh, look, I need that data as JSON because I've got a JavaScript framework that needs to access it, etc. Rather than having to rewrite that SQL from scratch, I can just wrap it with a with statement to get the raw data and then throw some JSON functions around it that came out in sort of 12, 19 and onwards. And rather than sending rows back to the client, now I can send a JSON structure back to the client. So it's great for taking existing technology that might be, say, in rows and columns or perhaps XML, etc., wrap it with a with statement to then convert it to something else for the next framework that's come along. Number 5, totals and subtotals. Someone comes to you and says, look, I need the employee salaries. I need a list of every employee, but I want subtotals at department level and I want a grand total as well. Now, hopefully no one's doing this. Hopefully no one's going, there's a query to get all the employee data. There's a query to get all the subtotals by department. And there's a query to get all the totals. That's obviously 3 queries to satisfy one requirement. That's an expensive way of doing it. We can actually get from 3 down to 2 using a thing called rollup. And what a rollup looks like is it looks like a group by, but what we do is we have one query now to get all the raw data, and we use a rollup to get all the subtotals. So that gives us the subtotals by department, and the total grand total as well. So we've gone from 2 queries down to 1. Now that's still messy because I've now got 2 sets of data. I've got the raw data and the totals, and now I have to somehow render that. So I have to sort of pluck off the raw data and then at the right point, put a subtotal in and then get the next piece of raw data and so forth. That's messy as an application programmer. And of course, at this point, if you're an Apex developer, you're going, Apex is going to do this for me. Why make it my problem? The Apex developers can have to solve that problem. And yes, you can do that with Apex. And you can see an example there. That's using these sort of control breaks and aggregates, etc. But don't forget, Apex has to be all things to all users. We give total freedom on how we do these aggregations. And so as a result, it's hard to come up with the perfectly optimal piece of SQL for every single scenario because we don't know what the user is going to choose. In the example here, when we do control breaks, this is the way we implement it in Apex. We get the raw data and we use an analytic function to pick up the subtotals by department as well as we go. And Apex itself is responsible for doing the final grand total. So there's a little bit of programming logic that Apex is doing for you on your behalf to satisfy that requirement. What if I said you could actually get from 2 down to a single query without analytics involved? And you can. You can actually do a group by roll up with the row number as well. When you run that, you get all the raw data plus the subtotals plus the grand total as well in one pass of the data. Now, obviously, that only satisfies that particular requirement. And this is what I was saying. If you have generic aggregation facilities, then you let Apex do its defaults. If you have, for example, a very large table that does some very hardcore SQL processing and you have a fixed format report that is only fixed in its format, it only does subtotals for department and total, for example, then you could consider a custom-made SQL like this one to get the maximum performance and sacrifice some of the flexibility. The key thing is you have the choice now. You have Apex with its flexibility, but perhaps slightly slower performance. For particular fine-grained requirements, you can smash in a dedicated SQL to get the maximum performance possible. The cool thing with this technique is all totals you could think about are actually possible. You can do group by cube. What group by cube does is look at all the permutations of columns in there. So group by cube department number of job gets me department number and job subtotals. It gets me department number, sorry, it gets me job subtotals, and it gets me department totals, and it gets me a grand total as well. So it takes all the permutations of the columns in there. And you can actually customize this to your certain needs. What if I don't want all the totals, but I want something more than roll up? You can actually do this thing called grouping sets. Grouping set says, as the line 3 and 4 suggests, I want a total by department number, I want a total by job and manager, and I want a grand total, which is just the 2 curly braces by itself. So you can literally nominate exactly what particular totals you like. And that may look sort of disturbingly familiar to you in terms of getting subtotals by various different dimensions, because guess what? We use grouping sets to actually implement our faceted search facility. If you delve into the debug behind Apex, you'll see queries like this with grouping ID and grouping sets. That's how we're using. We're using our own technology to accurately jump in and efficiently jump in to get totals at any particular nominated level. Let me check the time, 11:30. Number 6, the stop key optimization, AKA pagination, one of the things that we take for granted inside Apex. If I came to you with a very simple requirement, give me all the employees by hire date, the most recent first, well, hopefully no one's doing this. This is select some rows from the employee table. Line 3 is where row number less than 5, and then order by hire date descending. This does give you 5 rows, and they are sorted in terms of hire date, but it's not the most recently hired employees. It's not the top 5. We can actually read that query from top to bottom. The first thing we do on line 3 is get 5 random employees. The first 5 we find from the table, and then we sort them on line 4. So it's the wrong result. Most of us, I'm sure, are familiar with this and don't write queries like this, I hope. We solve this with an inline view. What we need to do is order the rows first. So that's the inline view on lines 3 through 5. Once we've sorted by hire date, then we pick off the top 5 using row num. Now, interestingly, it looks like we're getting all the rows, sorting them, and fetching the top 5. And keep that in mind because we're going to explore that further. Now, I should note that there are many ways to access this same sort of result here. One way is using an analytic function, still an inline view. You simply use the row number function to assign a sequence to each of the values and then pluck off the first 5. If you're using 12C and above, you can use the ANSI syntax, which is fetched first 5 rows only, once again, after the ordering. We actually remap that syntax straight back into that one. So when you write ANSI syntax SQL like that, we actually change it to this syntax and run it as per normal. At which point you go, man, that's a lot of SQL syntax. I don't need to do that. As long as I know how to do an order by, what's the difference? I'll let my app do it. And so often we'll see code like this. Now I've used Java as an example here, but it doesn't really matter. It could be PL SQL, it could be C#, .NET, doesn't matter. We see a lot of code like this. They're doing the same thing, but from first principles. Here's my query, select the employee rows and sort them. And then with my code, simply loop through the result set and fetch the first 5. I mean, after all, that really looks like what the inline view is doing, doesn't it? That's a really bad idea, and a really, really bad idea. And I thought I'd try to explain why you don't want to do that. Let's look at a demo. So I've got this table here called TX. It's just lots and lots of copies of the all objects view just to make it a big table. In fact, we can see it's got 10 million rows. It's about 1.5 gigabytes in size. That's not enormous, but it's big enough to stress out my laptop here, which will be fine. To see how the database sorts and what the cost of sorting is, we can look at one of the performance views. It's called $SQL Work Area Histogram. It's a carve-up of how sorting's operation is done and how much memory is required. Now, this is cumulative for the entire database. So even though I'm the only person on my database here, to actually see what the cost of a query is, I need to take a copy of this view before, run my query, and compare it with the results after. It's the delta between, because it's a cumulative total, that tells me how much work a query has done in terms of sorting. So I'm going to take a copy first called query before. It's a copy of that $VDOLAR view. And here's my good query. I'm saying use an inline view to get the top 10 rows. You can see it took 2.5 seconds. Let's go look at what sorting operations were done. Now, the way we read this is we've got a couple of columns, low optimal size and high optimal size. That's effectively a range between the number of sorting operations that were done. So if I read the first line, between 2 and 4 kilobytes of RAM, we did 2 sorting operations. Between 1 megabyte and 2 megabyte, we did 1 sorting operation. And between 4 and 8 megabytes, we did 2 sorting operations. Let's assume the worst case in all scenarios. Let's assume the high optimal size, just to keep the math simple. So I did 8 kilobytes, that's nothing. I did 2 megabytes and 2 lots of 8 megabytes. So 20 megabytes. That's pretty impressive because I used 20 megabytes of RAM, but my table was 1,500 megabytes in size. Yet I managed to sort it only using 20 megabytes of RAM. Let's bear with that. Let's move on. Let's do it now using the bad scenario. I take a copy of my SQL Work Area histogram, and now I'll do select order by, and then fetch the first 10 rows. So I didn't use an inline view. Now already you can see it's slower. Instead of 2.5 seconds, it took 6.7 seconds. So that's penalty number 1. It's going to burn you in terms of performance. Let's look at the sorting distribution here. We did 2 operations of 4 kilobytes. That means nothing. We did 1 operation of 2 megs. That's nothing. Oh, we did 2 operations of 2 gigabytes in size. I don't care how big your server is. If you've got 500 users all asking for 2 to 4 gigabytes of RAM at the same time, your application and your server is toast. Now, what's the difference? How do we get this fantastic sorting performance with only 20 megabytes when surely we have to sort 1,500 megabytes of data? Conceptually, you can think about it like this. Because I told the database I only want the top 10, the database knows that now. And so what it does is it simply says, okay, I've got to read my 10 million rows. I'll read the first 10 and sort them. That currently is the top 10 rows out of the first 10. Read the 11th row. Does it fit in this set in terms of order? Yes. Put it in, throw one away. Read the 12th row. Does it fit? No. Read the 13th. Does it fit? No. Read the 14th. Oh, yep, that's in the list. Put it in, throw one away. I must read every single row because to find the top 10, I must consider them all. But I only ever had to sort effectively a small set. In the second example, because the database didn't know I was only going to fetch the first 10, we just simply said order by. It says, well, I may as well sort them all. And one thing to be aware of is I look at this final result again. these columns here, I didn't explain. Delta opt, delta one, delta multi. Delta opt means I could do something entirely in RAM. All my sorting operations are in RAM. When I got to this 2 gig limit, my laptop doesn't have that kind of gear. It actually did this thing called a delta 1, which means I tried to sort in memory, couldn't, had to dump it out to disk to bring it back in. That's one pass out to disk. So not only was it slower, not only did I need 4 gigabytes of RAM for sorting, your machine can't do it. And so it dumped it out to disk, which is why it was so slow. So I can't stress enough. Let the database know that you want to be fetching the first n rows, and your application will run so much better and your server won't go up in smoke. So this is the kind of stuff you want to do. Now, how do you know? How do you know if this is using the really cool fast sorting algorithm and not smoking up your database's RAM? These are the things you want to look for. So where we're at was, we said, if we want to have these fantastic sorting performances, how do we tell? How do we see just from the explain plan that we're actually getting the right kind of sorting operations? And this is the key. You want to see sort order by stop key. If you just see sort order by, where you're doing a big, huge sort. So sort order by stop key when you have an inline view. If you're using the ANSI standard syntax, you look for Windows sort pushed rank. Pushed rank is the keyword that says we're using this optimization to avoid smashing your server to sort the entire result set. At which point you're going, yeah, thanks for the theory, Connor. I didn't really need to know about memory structures inside Oracle. Apex is going to do that for me, which is true, but it's going to do it within the confines of the fact that Apex has to handle all possible scenarios. Because let's face it, when you go into Apex, you can write any query you want. And so Apex, just like all applications, has evolved over time. Before version 18 of Apex, interactive grids, because it was a new piece of technology, almost always guarantees to use this sorting optimization. However, the older pieces of functionality, classic reports, interactive report, didn't use that. They didn't use that sorting optimization, so you could get hammered with big sorts. And obviously, as we evolve with the application, 18 onwards from Apex, all these things now use the sort key optimization, which is great. If you ever wanted a justification to upgrade, there you go. Go see your admin and say, how come we're using so much sort memory? Because we're stuck on an old version of Apex. Move to the later versions and you get these functionality benefits and performance benefits for free. Now, I will caveat those 3 ticks with the fact that Apex has to be all things to all people. Don't forget, when you create a report, we don't know if you're going to come in and type in the single most complicated query in the history of the universe and then run up Apex and say, look, I want to be able to get that in a paginated fashion. And so one of the things I'd encourage you to do is when you're running your Apex applications, fire them up in level 9 and then run some paginated queries for your reports. Because in the debug, we will dump out the SQL statement and we will dump out the execution plan. And for example, here I chose a query that was complicated. And as you can see, Apex, the query was complicated to the extent that we had to do sort order by. We didn't manage to get that optimizer benefit. And we can actually see in this case, we were using a row number analytic. Now, one of the things you can always, a good thing to try with Apex is we can actually implement pagination in multiple ways. So if you are seeing sort order by and you are worried about the performance, especially if this is a very large table, look at using this hint. It's a special Apex optimizer hint. Apex use row num pagination, which flips over our pagination mechanism. Carsten wrote a great blog post on that in the link at the bottom of the screen there. In that case, the same query now, we can actually see we're using a slightly the old inline view format here, and we got the sort order by stop key. Now, don't get me wrong, I'm not saying you should use that hint for everything. What we have seen is sometimes this is better, sometimes the other one is better. It really depends on the content of that query that you've customized yourself. So my recommendation is always check the debug level because we had the execution plan right there and you can choose the technique that's going to be best for you to get the maximum performance out of your Apex queries. In the worst case, you can actually roll your own pagination, but hopefully that's the absolute worst case. The more often you can just leave Apex to do its thing and if necessary, use that hint, the better off you'll be in terms of maintenance. Number 7, How are we going for time here? Ooh, we might squeeze a couple more in. Most of us know about analytics. And we have this thing, once we see the over clause, we know that we're talking about analytic SQL. Most of us are now familiar with these. They came out way back in 8.1.6. If you're not, there's literally a selfless promotion, a 30 video tutorial series at that link, bit.ly.analytic_SQL. But I'm assuming that most of us have used some of these at some stage now in our lives for pagination, ordering, etc. But let's talk about a slight extension to analytics, which less people know about. If my manager, Stephen, comes up to me and says, show me the lowest salary for each department. That's trivial. I know how to do it. It's just a normal group by department number, minimum salary. But often we get those requests to then enhance an existing SQL. I need to know who has that lowest salary as well. And if you're anything like me, the first thing I go, that's easy. I just add the employee number. And then I get this problem. You can only group by the non-aggregated columns that you have in your select statement. And so this is sort of intuitively what I wanted to do, but of course I can't have employee number here and not have it in the group by. If it's in the group by, I'm no longer getting the lowest salary for each department. We have a thing called the keep extension inside analytics, and there's lots of uses here, but here's an example of how I could do it. I do it even though I'm grouping by department, I'm getting the minimum salary. I can also say, I want the minimum employee number, but my definition of minimum in this case is the person that's ranked first in order of salary. So it's effectively saying, I want to pick up the employee number based on the person that has the lowest salary. Hence my result is now what Stephen wants. Employee 7934 is the person that has that lowest salary. Now, there were a few more features, but seeing as we lost 5 minutes, I'll just jump to our last one. Most of the things you've seen today are a subset of what I call, are you giving me the silent treatment? And the best way of describing that is to talk about my mother for a second. My mother's getting quite elderly and she has some plants in pots at home, much like this one. And she talks to them. And she says heartwarming things to them every morning when she waters them. And her premise to me is that talking to the plants makes them grow better. Now, I think maybe she's getting a bit old and she's just playing crazy, But anyway, funnily, while I think that is nonsense, talking to your database will in fact make it faster. Let me see if I can demonstrate that. Here's an example. I've got a very simple data model here. We've got some stores. For each stores, we have customers. Customers come in and buy stuff and therefore they have sales. It's a 3-table data model. Here's a kind of query we might run against that data model. For the stores, customers, and sales, where someone has spent more than $10, find the highest sale amount for each particular product, hence prod ID max amount on line 1 there. Now, how do I best run this? Which table should I start with? Do I use a nested loop, hash join, sort merge? Luckily, it's not our problem. The optimizer has to work that out, and this is what the optimizer came up with. It said, I'm starting with customers, going into stores, and then doing a hash join to the sales table. And often as developers, we get asked if there's a performance issue, can you make it better? Can you do better? And what do? Do we rewrite the query? Do we add a materialized view? Do we add indexes? Maybe we just give up and move the whole thing in Hadoop. Here's where I say, sharing your knowledge, talking to your database makes it faster. This is our final demo. Here's my stores table. Here's my customers table. Here's my sales table, all empty. Let's put some seed data in. I'll create 50 stores, random data, 5,000 customers and 1 million sales. So I've got some nice volume in there. We'll put the normal stuff on. There's some indexes on the various columns. And here's the query we saw in the slides. And just to prove I wasn't lying, you can see it comes up with the same execution plan as we saw on the slides. Now, let's talk to our database. Let's tell the database what the primary keys are. Let's tell the database which columns are always going to be present. Let's tell the database what the foreign key relationships are, what the rules between tables are. Here's that same query. Now, here's a challenge for you. Now that the database knows more about a data model, I wonder which table it'll use first in our execution query. Stores only has 50 rows. Customers have 5,000. Sales has 1 million, but sales is the only one that has a predicate on there of amount greater than 10. So it's still a bit of a challenge. Let's see what the optimizer now does. It doesn't need to read any table at all. That entire query, a three-way join, can now be satisfied by reading just an index. How insanely clever is the database optimizer? It is mind-bogglingly smart as long as you share what you know with the database itself. So let's wrap it up so I can pull this thing to thing and we can wrap up this incredible 24 hours we've had. SQL is very cool. It's very powerful. The amount of power you can get is just, it never ceases to blow my mind every single day. And the cool thing is, if you're writing less code in Apex, you're ending up with faster, more scalable Apex applications. And what's not to love about that? And it's never too early to start upskilling, to increasing your SQL skills. This is my son, Max. He's an avid reader of SQL books, especially ones that are authored by myself. A little bit of fun there to finish. And as we saw in the TV show 24, we've come to the end of our hour. Not really, we've got 10 minutes left. But on that point, thank you very much for joining. Thank you for coming back onto the Zoom call after we got booted off. And I'll hand over now to both Martin and David. Thanks, everybody.
Well, thank you, Connor. That was an awesome, awesome talk. And I don't know what happened with the Zoom thing. I think we just burned out the account on that. So yeah, no, that's great that we came on in five minutes. So first of all, thank you, everyone. I have to concede to Joel. When we first started talking to Joel about this, I said, when he talked about 24 hours, I was like, that's too long. It wasn't going to work. And I'll eat my dust on this. I was completely wrong. This has been a huge success. Thank you, everyone. So I have a couple people to thank just for this whole thing. So first of all, Adrian and Ping and Trent Schaefer. You haven't seen them online, but they have been behind the scenes. They were the people that kicked this off with me. So thank you to Adrian and Trent. They're the co-founders of Apex at Home. I also have to say, Joel, you and your entire team have helped behind, oh, there's Adrian. You have helped behind the scenes as well as providing all the moderators. So those that aren't aware, while you guys were up, someone from the Apex team has been always up recording these sessions, are going to be doing post-processing. Bo English from the Apex team, she's also done some moderating, but she's also helped do a lot of things in the back end, helping us with the wording, and she's going to be the one sending out those hoodies as well, so those that get them. And then obviously all the speakers and the attendees. I mean, we had some great numbers come in. At some points we were over 500 attendees, and we don't even know how far the reach this is going to be once these recordings go on YouTube and Ask Tom. So again, thank you guys. This was well beyond what we thought when we first talked about this idea, and it was big and small, and this is, or is pretty small. And this is the awesome thing about this Apex community is it's not just been one person or one company, it's been the entire community that has absolutely stepped up and all gotten together in a difficult time for all of us to do a great thing. So that's what I'll leave. And Joel, do you want to finish with some final announcements?
Joel, just one thing I should say. Happy birthday, Niels.
Oh. Thanks.
Happy birthday, Niels. Yeah, I mean, you basically stole all my thunder here. I was going to say, I'm kind of amazed that stuff was, it really went off without a hitch, other than that final Zoom snafu, which honestly, I put a tweet out right now. We should be proud that we broke Zoom. That was what I wanted to do, and we effectively broke Zoom. I don't think they planned for anybody nutty enough to do more than 24 hours of a session. So I want people to understand that the Apex community is the envy of all others at Oracle. Connor, I'm not embellishing this, am I? And I think this was just an outstanding demonstration of why that is. So to you, Martin, and Adrian and Trent, you guys contacted me. I looked on this. This was an idea presented to us on March 13th. So it's basically nothing existed other than an idea. And in a month's time, you executed this. Oh, you originally planned for 8 speakers and you didn't run away when we suggested 24. But what a feat to have 24. And so that's a lot of work to contact all these people and schedule them and find when they can be available. I mean, that's a lot of work. And I know Bo on my team was very busy. There's a WhatsApp discussion group that everybody's in. I am, and I never read it because it's busy all the time, and I don't have. So I know stuff is going on there. So yeah, Bo is a huge help. I'm grateful to everybody for the office hours platform. They actually this was easy, and thanks to Blaine and Connor for moderating this. I actually that it was perfect. For someone who has to prepare for conference presentations and even webinars, to do it well, it takes a lot of time. It takes a lot of, for every 1 hour of a webinar or presentation, it's probably a good 10 to 15 hours of practice and rehearsal and refinement. And so I'm really grateful to all the speakers who are so gracious with their time. I mean, this was just world-class talent. And I think, like you said, Martin, that this is going to go a long way as people capitalize on these recordings for years, right? Certainly the next year. And lastly, really, I'm just grateful as many people from the Apex community showed up. Somebody from marketing contacted me today, and they want to do a blog post about this. From the developer relations, and there's nothing like this at Oracle. So I'm grateful that everybody attended. Maybe this is going to happen again next year. And for people who were in attendance, maybe you consider sharing your knowledge with the community next year. Why not, right? I think it's a good idea. So yeah, just an amazing event. I could not have imagined it could have gone any better. So thanks for being the inspiration and all the hard work there, Martin, and Adrian and Trent.
It's been awesome. And like you said, when we first talked about it, you kept telling me call this Apex at Home 2020. And I said, no way, this is going to be a one-time, one-shot deal. And again, I was wrong. I should just concede to you each time we talk, Joel. We'll look at doing this again next year. We kind of, as Joel said, this really happened scrambling together. It worked really well. Everyone pitched in. So if things work out, and we'll have to work out the timing, we'll look at doing it next year. But first, I think there's a lot of people, and I know there's Rick who's been on all 24 hours. Get some sleep. And thank you everyone again for attending. It's been an awesome event, and hopefully we'll do it again next year.